recording of the webinar that you can share with colleagues or students and folks at the district level, if you like, and it'll be up on the mathmodels.org website, along with the presentation materials and the paper that our presenter's talking about. So today we have Jack Diekman, who is the Director of Research at YouCubed, Stanford, and we're very excited to have him. This is part of a webinar series that is kind of designed to kind of help folks think about math modeling and how it can open up opportunities for students either in the classroom or through participating in contests or competitions. The idea is that math modeling offers students these open-ended problems where they can collaborate and use the mathematics that's in their tool bag in a different way instead of kind of thinking about more traditional ways of learning mathematical skills and then applying them right away. Instead, thinking about pulling things out of your tool bag that you have put in there maybe even over years and apply it to a real world problem that hopefully has some connection to students. So I'd like to just put in a quick plug for our next webinar. It is Wednesday, March the 24th at 4 p.m. So we hope you'll join us. And again, even if you have colleagues who were interested in coming today and weren't able, they'll be able to access the slides and the recording. So without further ado, I'd like to hand it over to Jack. And thank you very much, Jack, for being here. And thank you, participants, for being here as well. Oh, and thank you, COMAP. COMAP is sponsoring this for us.
Maria, thank you for inviting me and COMAP for sponsoring this event. We're always happy to share illuminating research about new ways about thinking about mathematics and what we can learn from them. Just with it, in terms of introduction, I was a teacher, a math teacher in Texas at the middle school and high school level for many years, and then I went to graduate school here at Stanford with Jo Bowler, and I worked with her. And now I work with her and her team at YouCubed. And YouCubed is a center, for those that you might not know, is a center at Stanford that focuses on innovative math materials, K through college, with the idea of promoting this approach called mathematical mindset. And Jo Bowler has written a lot about this in her work. And mathematical mindset, I think I want to talk a little bit about that because it gives some understanding about where our perspective comes from as we approach the research that I'm going to be discussing with you today. Mathematical mindset is really the brainchild of Jo, and she threaded together very carefully the ideas from positive psychology, Carol Dweck, and sort of mindset, fixed mindset, growth mindset, which was in the air. But she joined that with the latest neuroscience findings about what we know about brain plasticity, what we know about the effects of anxiety, for example, on the brain and how that affects learning, what we know about using our fingers when we count and the connection between our body and the brain and the parts that light up in the brain when we use our fingers to count, for example. So she joined the field and the understandings from psychology, neuroscience, and taking the best of what we know from the math education literature that we've known for a long time around problem solving, open tasks, cognitively demanding tasks, formative assessment. These things have a long tradition in the mathematics education literature. So threading those together, she developed an approach at YouCubed called mathematical mindset. And we've actually been testing that in not only in materials that we develop for people, the people use a lot of our tasks on the website, but also we've been using it in interventions. We have a summer school intervention that we led at Stanford in 2015 that had phenomenal results with middle schoolers. And then we replicated that 2 years ago in 2019. And not only did we replicate it at Stanford, but we replicated that in, I think, 17 different school districts across the country and in Scotland and in Brazil. And again, we got very strong results. People taking that approach and implementing it in their context with sometimes 5th graders, 6th graders, 7th graders, kind of in that area, following the same teaching practices and the same ideas there. And so this mathematical mindset is kind of the perspective that we bring to the research at hand. So I'm going to share my screen a little bit and kind of tell you the story of how this research developed, what we learned from it, and I think the wider applicability. I know that in the audience we might have math specialists at the district level, we might have math teachers at the collegiate level, at the high school level, all the folks who are interested in mathematical modeling. And so from your vantage point where you sit, this question about what kind of mathematics is being offered, what messages are being sent about mathematics, and today in particular, the focus on gender. What insights can we glean from this research about gender? So that'll be our kind of our guiding question for today. Okay, so I'm going to share my screen here. If you have questions, please feel free to put them in the chat. I can't follow the chat as quickly while I'm talking, but we have Maria Hernandez, who's also helping us here, and she'll be watching the chat. So if there's something that she sees patterns of questions, I'll ask her just to interrupt, and I'll back up and we'll entertain that question. Okay. Share here. Okay. So the focus of this study is around gender equity in a collegiate mathematics competition. That's the context for the study. And as I said earlier about mathematical mindset, which is the teaching and learning approach that we've developed at YouCubed, we think about it in two ways, just to simplify the conversation. If we think of the sort of two versions of mathematics, one version of mathematics is what we might call school mathematics. It's very performance-based. It's very rule-focused, lots of memorizations. And in general, the curriculum and the experience of the students is around bits and pieces about mathematics. So most of us experience school mathematics. And despite this, many of us fell in love with mathematics and pursued it and discovered hopefully a more connected mathematics in our more advanced study of mathematics. But for sure, school mathematics, despite all the wonderful work that NSF has done, the National Science Foundation, and many, many good curriculum, despite that, the culture, the school culture of mathematics is very entrenched around these practices, around answer-focused culture. And on the one hand, this makes things very easy for teachers and students because it feels very clean. You know, what's the answer? What's the value of X? It's -3. We can move on very, very quickly. But when we ask, how did you get that answer? What if we were working with rational numbers? What if this number was a negative instead of a positive? In other words, once we start delving deeper, then it becomes a different kind of work, a different kind of experience. So school mathematics is also very good at sorting students. So when a teacher asks a question, it's normally the first few that raise their hand that are perceived by others as being more competent in math because they can memorize faster, they can produce faster. And so there's a focus on speed, and there's a focus on getting the right answer. So we know, for example, in mathematics, when students don't have the right answer, there's a strong stigma around error because the idea of being wrong is often framed as being incompetent or not knowing what you're doing. And so that stigma obviously produces anxiety, produces people to not want to risk. And so I'm telling you all these things that we all know because we all experience school mathematics this way. But I'm saying this because I want to describe the features of school mathematics and describe them in more detail so that we can compare it more systematically to the other version of mathematics that we're aspiring to, and I think is very much aligned with COMAP and the modeling approach. So we think of this other mathematics as being more learning oriented, which is around not just performing, not just showing that I know, but one whose objective is about trying to understand patterns, trying to derive results, making use of previous results, looking for connections both within mathematics, within the domains of mathematics, as well as outside of mathematics in applications. And that's really where I think COMAP and modeling competitions, that's going to be our focus today, that's where it really sits, is connecting inside and outside of mathematics. So just by looking at this, you can see the stark contrast between school mathematics and this other that we call maybe more authentic mathematics, disciplinary mathematics, or just mathematics as we think about it more generally. Okay, so thinking now, trying to situate this as background to our study, Saul Garfunkel came to Joe and with an interesting proposition around participation patterns in the math modeling competition. And he shared with us some really interesting data. The first graph you're watching are the number of teams, or number of really participants, I think, since 2010, all the way to 2018, which is when we started the study. So you can see a stark, a consistent increase in just participation, which is great. So this means that the competition is really tapping into an unmet need and the applicability now of developing the skills of modeling. So Saul brought this data and then he disaggregated it this way as well. When we look at male versus female, we take that same data and we start cutting it up. We see a trend, and I'll let you look at this for a minute. So one thing we notice is that even though every year there appears to be more male participation than female participation, you still see an increase in the female participation every year as well. So there's still a gap. We're not at parity yet. But if you notice, every year there's more women increasing and participating. And not only that, but we'll see in other results, women are also placing and winning in these competitions as well, closer to parity as well. So they're not just participating but not scoring well, they're participating and scoring well. That's a real important point. So why might this be, was the question. When we look at 2018, this was the number of students and the number of participants. So there was 57% were male, identified as male, and 43 identified as female. So this is really different from most math competitions, and especially for the placement data of how many women actually placed whose papers were recognized. So the study started with this driving question. What are the factors that would account for high participation of women in comparison with other math competitions for which we don't see this type of female participation and female placement in award-winning papers? So our research around this was to sort of have a multi-methods approach. We interviewed university faculty, especially those that sponsored the competition. Some of those resided in mathematics, some of those resided in the engineering department. And we asked them a series of questions around why did they, what was this program doing for their students? Why did they continue supporting the MCM competition? And how did they use it with their students? How did they recruit students? What other things did they do with this competition? So for example, some of them used it as a mentoring experience. So we're really quite surprised at all the different ways that university members responded to this. So we had interviews. We also conducted surveys with the same people in the US. We did a field study where we have 2 teams of people who went to 2 sites. And we observed them actually working. I was one of the participants. I went to a school here, university here in California, in Northern California. And we sat down while the team was working and debating and trying things out. And we recorded them, and we took notes, and we tried to understand their process to get kind of some in-depth understanding of the practices that were going on in this unique environment, to try to understand. Again, the driving question is, why is it that women might be more attracted to this environment, or what factors might be supporting more equity in this? So we also interviewed the teams, and then we did a larger survey of all the people that we could track down who had participated in this competition the previous year. So we got 1,300 people in 10 different countries. So a small sample, but still trying to understand what might be going on. So as many of you know, in qualitative research, it's hard to go to one source and get the definitive answer. And so in research, what we try to do is take one piece of the puzzle, the other piece of the puzzle, the other piece of the puzzle, and then sort of triangulate and say, what's coming into focus? And so that's what we did in this study. So the results are, for the first part, was case study. In other words, looking closely at what happened in one particular group that we observed. So there was this was done in a large Western public research university, and it had a long history of participating in MCM. So there was already a deep sort of culture of every year we do this, it's been normalized, teams were easy to form and so forth. They had lots of different teams. And so within that context, we embedded a researcher who sat with the team all 4 days, recorded, observed, interviewed. We tried to be as unintrusive as possible, but sometimes during the breaks and lunch, we interviewed. We collected their work and so forth to their final product, especially, to be able to have more artifacts to understand their process. So in this team, we've anonymized them, but here we have a student that we'll call Samuel, who identifies as male and African American. He's in the engineering, physics, and applied math major. He's interested himself in renewable energies, and he has some experience with math competitions in high school. He's the first member of this particular team we observed. Then there was Monique. Monique identifies as Asian American, female. She is an aerospace engineering and physics major, and she wants to be an astronaut. So she, unlike Samuel, she has limited experience with competitions. She's done a few in middle school math competitions, but nothing since. So she wasn't as experienced as Samuel in terms of MCM. And then there was Frank. Frank identifies as white male. He is also an aeronautics and astronautics major, and he's interested in spaceflight. So he's never done math competitions before. So we're seeing in this team diversity along different lines, ethnicity, gender, experience, and interest. So the problem that the task that this team chose was the energy production one in 2019. I think this was February or March in 2019. The problem, basically, if you recall, the problem tells them that there's 4 states that want to form an energy compact for renewable energy. And so they have to help the governors set goals to create this interstate compact based on data analysis and modeling. And along with the problem of this data energy use in different states, there's some sub-questions. And the teams work up a sort of final proposal up to a 20-page solution, explaining their process. And then they do, I think also, there's a technical paper, and then there's that 1-page memo intended for the governors to explain their recommendations to lay people. So I'm sure you're familiar with the structure of the contest, but just for the sake of, if we have any in the group who may not be familiar with it. So there's sort of a ill-defined problem with a guiding question, some resources and data, and then the group starts to dig in and work. And this is the process that we were interested in understanding. When we looked at how students spent their time, just on the first level of analysis, this may be too small for you to read, so I'm going to read the little labels at the bottom. At the highest one, discussing the model was the time was spent most on that activity. Then working, sort of like work periods, and checking in, brief check-ins with each other. So it's sort of like when they were discussing and then they take a break to work independently. Those are the top 2. Then they spent time discussing their writing, problem solving, thinking about logistics. There could be around resources that they needed, where they could find things and so forth. Discussing the graphs. This is now on the lesser side. Deciding on a question. So this team didn't spend too much time on deciding on a question. Discussing the problem itself, discussing the data, and discussing the program. So this represents, I think, a total of like 37 hours. So you can see the relative weight of how students distributed their time. And we see that the bulk of the time is around discussing and working, toggling between discussion, working, and then we have some discussion of writing. So those, those activities are seem to be what the team prioritized. And we think about that as part of the collaborative nature. What's going on there? The negotiation of meaning, the arguing, the taking different stances, working things out, considering this perspective or that perspective, backtracking, trying something out and then deciding, no, we can't go that way. And all of those process of negotiating meaning are all within that process of discussion and then working and checking in. So we see that our direct experience with the competition was that there was another team that also had, we also observed directly this way, and they had a similar but slightly different experience in that team spent less time with the initial discussion. So what they did was they first went through, selected the problem, analyzed the data. They went off on an approach, and they went pretty far. They spent the first day on that approach, the first of 4 days on that approach. And then the second day, they realized that they hadn't fully understood the question, and that most of the work that they did on that first day really wasn't going to help them. So it was a bit disheartening for them, but it was a really powerful learning experience for us, I think, around the initial understanding and how useful it is to be sure that to do that work up front to negotiate that, because I think that they were so, this team that the second team that I'm talking about, they were so ready to jump in, which is great. We love their enthusiasm. But on the other hand, it they needed to do a little bit more thinking. What's wonderful, though, of course, is that the competition is 4 days. So they had time to go back, think through, and learn from that and recover. So we think about that as another wonderful aspect that most math competitions don't allow that, that possibility. Here's some of the reactions to some of the work that we heard in the interviews that we did. One student said, I thought it was interesting working for so long with people and looking how far we got after the competition. It definitely exceeded my expectations. We had like a 40-page paper. So just in terms of the sheer volume of work that was produced together. And these students took short breaks. They didn't, they hit it hard every single day. So I think this is what led to the impressive results. Monique said, I enjoyed getting all of our ideas down. I think that the most satisfying part was having everything come together, having a model that we really believed in. So you see that this experience wasn't just sort of a technical exercise or a rational exercise, but there's something satisfying. Thinking about the intellectual satisfaction that we get when we work on a meaty problem, when there's enough resources, including team members, and time to revise. And it's something that you can really be proud of, really believe in. So right there, we're engaging emotion, we're engaging the whole self, which for people who are in the school mathematics culture, it doesn't happen because school mathematics doesn't allow for this. School mathematics, remember, is about the answer, going quickly, next thing, it's very performance oriented, not understanding. So here we see that it's more holistic in this way. The other student said, this is kind of how I imagine engineering would be. You kind of get to know your team, late nights, eating dinner, while thinking about your problems. It's super fun. I love that. So this person is already thinking about his expectations around his career, where he's headed, solving problems, working together, just sort of diving in, sort of being immersed in the problem. But also knowing the social nature. He's really mindful of the social nature of the work, rather than the idea that sometimes we have that, all mathematical people or all STEM people work by themselves and are independently brilliant and then come together and just reveal all of their thinking. While that might happen, it's really not the norm. Mathematics and math-related careers are extremely social and extremely dynamic in this way, but we don't often present them in schools, so students don't have that experience, especially extended work. Usually most math problems have one right answer, and if in the first 10 seconds you don't know the answer, then then you're lost. So it's this little short, discrete little pieces instead of longer, meaty problems that are going to require more careful thinking, extended thinking, collaboration, bouncing ideas, and letting ideas incubate. Not forever, but letting them incubate so that you can see what's the next step. Okay. So that was the first sort of part of the research, was a case that we built. The second part looks at what we learned from the student surveys and the interviews that we received. So I'll share some of those results here. Okay, so what do students value most about the competition? What was it, in particular, why was this competition appealing to women? Some of our survey data and interview data help us understand this more carefully. We used our analysis of the surveys and the observations, and we produced 3 different themes, which we've graphically represented here. And we take this notion, each of these little triangles we'll talk about and present some data for them. But we think about the fact that there was something holistic about this experience, that it wasn't just, you know, your brain. It was also the rational part, the emotional part, your whole self, your interests, what you cared about, your future. Some of them thought about their mathematical futures and so forth. So in that, we try to organize these things, and we came up with this idea of the key factors were collaboration, that students had an opportunity to collaborate, that the mathematical task was multidimensional, that there was more aspects to it. It was a meaty math problem, and that students had the freedom to create, freedom to invent, to analyze and create together, to critically create, let's call that. So all that together, we think supports students in their sort of rewrite them for themselves a different mathematical future, especially for women who often get implicit signals that mathematics is too difficult or that it's not for them and so forth. So we're going to unpack each of these themes with some data. So we asked students, why did you enter the competition? And we have a little word cloud that, you know, from the results of the student interviews, they talked about communicating, leadership. It was very sociable, teamwork, writing, debating, learning. So there were a lot of positive reasons that attracted this, you know, this experience to students, why students sought this out. And here we think about, again, engaging the students as whole people, not just as sort of brains in a jar, but whole people with, you know, lots of different aspects and facets to them. Some of them were great at writing, some of them were great at explaining, some of them were consensus builders, some of them knew how to take leads, some of them were great at finding resources. I mean, there were lots of different skills that not one person had, but the team had. And so there was this way of bringing all of your skill sets to bear in a collective way, and, you know, sort of for the good of the team. So that sets the stage for the whole person. If we look now at the first component of collaboration, after reading a question, this is what one student would say. We'd read it 3 different ways or have 3 different approaches to the problem. And a lot of times we'd have a whiteboard completely filled up trying to explain our views on the problem. And eventually you got to step back and open your mind and realize, fully interpret other people's ideas. So students really had to have a different kind of listening, not just for do I agree or don't agree with you, but do I understand what you're saying? And I was there when the students were filling up their whiteboards with all kinds of, you know, long, protracted explanations, trying to make their case. And each one then had a chance to explain and sort of make a pitch. And the others would ask questions, they would think and try to see where you're coming from. And then after those 3, after each person went, trying to figure out, okay, so now what looks like the most efficacious approach here? So there's definitely a lot of collaboration that was part of the process. It involves a lot of collaborative work, allowing people to have input into the solution of the problems. One student said, I'm a firm believer that better solutions are created when people work together. So for sure, collaboration is part of that. And I don't think anyone needs to argue against collaboration, but still, even though we know it's a good idea, extended collaboration doesn't always happen in classrooms. Why? Well, sometimes teachers will say, it's too difficult to manage. I don't trust the group. I don't trust that they're all going to do their work. Maybe one kid's going to do the work and the other ones aren't. There's lots of reasons why teachers don't put into practice what we know about collaborative learning. Some of it requires more teacher development, more teacher support, but sometimes it's the curriculum that's very piecemeal. They're not very discussion-worthy tasks for them to do, and so forth. So the point is not to fault teachers. Remember too that teachers don't have that experience of themselves of being problem solvers in groups and teams themselves when they were in school. So it's difficult for them to imagine this. The second, excuse me, the second aspect, along with collaboration, was this multi-dimensional mathematics. And so what do we mean by multi-dimensional? Well, multi-dimensional is when problems are, have more than one approach to them. So the problems are more creative and closer to life. The competition motivates us to think, this is a student talking, motivates us to think more deeply about the world we live in, which can't be achieved in other competitions. So here, mathematics wasn't just an esoteric exercise. Here, through the application of modeling, students report that mathematics is helping them understand their world, which is a really profound and satisfying way of using mathematics. So we use mathematics to understand and explain our world. We use it to predict our world, to predict things, which is what models do. And we use mathematics to have an impact in the world, to matter in the world. So in this case, the renewable energy, for example, when we make a recommendation, and if a decision maker, policymaker can be convinced through our mathematical and scientific work that this proposal is the way to go, then we're having an impact in the world. So that's very, very different from a kind of a closed mathematics where it doesn't have that kind of connection to the sort of broader reality. And don't get me wrong, pure mathematics is wonderful. And all of us have experienced sort of the beauty of that. And when it's done in an open way, that can also attract people. But the applied mathematics, and when it's contextualized and when it's something that seems to matter in the world, that also has its own appeal. And that is unfortunately infrequently available to students. Another student says, we were using knowledge from a bunch of different classes, and the classes overlap a little bit, but you don't really see the actual overlapping until you have to apply them to something. So here was a math major talking about, I had studied, regression. I had studied modeling. I had studied, linear programming, or I'd studied all of these different classes that in and of themselves, they were wonderful skills. But this program or this competition asked students to put all that together to connect something from this class, and put it to use in a novel way. And I think that's what made this student very excited about the competition, because she had not had that experience before. Finally, the freedom to create. We don't think about, or many people in the world don't think about mathematics as particularly creative, because it's often about getting the right answer in lots of people's minds. And so what we saw in this competition, we call freedom to create. And it has, here's some sort of quote to kind of illustrate that for us. Student says, I've been a student my whole life. And so it's kind of nice to test our skills, but not being in such a harsh grading criteria. That's definitely different. This competition, she means, is definitely different. It makes you think about the effort more, and you're willing to take more risks, I feel. So notice here that the participant is making a comment about the harsh grading criteria that sometimes is part of mathematics classrooms, especially when it's in a performance culture, where we're looking for specific answers. The problems are very closed. We're looking, do you know this procedure? And there's nothing wrong with procedures, but it's like the diet is only about that, instead of it having a richer range of experiences. And so here the student is saying, I could get out of that, box, and I could start thinking differently about things. And so we would call that more creative. and more willing to take risks. So we know that inventive thinking happens when we go beyond what we already know. So if we only replicate what we know, we're repeating procedures and probably gaining mastery there, but we're not pushing our boundaries. We're not going further than what we can. To do that, we really need to be able to feel that we can take risks. That's really where the learning happens, is when we push against our, the repertoire of what we can do. Another student says, my favorite thing was definitely the feeling of using all of our resources that we learned in our school for something that's not a test and not a graded project. But it was really interesting because we're really testing their skills that we know and that we've learned without being on that testing schedule. In other words, 2 hours or whatever the time is for testing. And that was huge for me because I've never done anything like that. And that was definitely by far the best part for me, is just getting to those practical things and kind of show them what you know. So this, again, this competition has sort of an integrated way of sort of pulling all the pieces together, attacking it on a really substantive and important problem, and then producing something that you can be proud of. So that, we call that as also freedom to create. There's a creativity aspect that becomes possible under these circumstances. So those kind of, we talked about collaboration, the multidimensional mathematics, and the conditions that allowed students to feel like they were ability to create. We think that these three contribute to that center triangle, that this opens up for students their mathematical futures. And so when we looked at some survey data, we asked which aspects of the competition were particularly appealing to you. And so here we have the bar graphs of them, and we've separated it by gender. I don't know if you can see at the very bottom, but the purple are respondents who identified as female, and the green one is those that identified as male. So I'll just go through some of the highlights here, and I'll give you a minute to study the results as well. So you might ask yourself, where are the greatest gaps? Where is there more kind of commonalities? It's interesting that, collaboration, even though lots of men found that useful and a good and attractive part of the competition, it was by far the strongest for women. So this is not an either or. It's like it seems to benefit both, but it seems to especially be attractive and beneficial towards women. And you see the same thing with more time. Look at the global one. The fact that this was a global competition, maybe I should go through these. Let's see. The fact that it's collaborative, the fact that there were multiple strategies, the modeling aspect, the fact that this was a global competition, the fact that the competition gave more time to do the problems, that it allowed you to use more resources, you could work with your mentor, opportunity to learn. It helped my CV, sort of on the more pragmatic side of things. We could create a product, and we got to work with friends. These were all the reasons that we offered as possible ones, and including some that they were able to write in. And when we aggregated the data, these were the more dominant patterns. So moving on for time, in terms of a new mathematical future, what we see is that 67% of students say that the competition will change their mathematical pathways. In other words, that the experience of being in COMAP's, CMC's competition, no, MCM's competition, either they're going to take more courses, change their major, look for something in more mathematical work. In other words, it like a magnet, it attracted them to more STEM and STEM related fields. So that's a really powerful, finding, a powerful impact of this competition. It's not just that students feel good and that they like collaborating, but it's having some import into their life decisions. So we take that, as an extremely important finding, and illuminates that the conditions of the MCM are worth studying and worth understanding and worth seeing how we can make those available in more settings besides just a competition. So in terms of new mathematical futures, one student said, I have an unforgettable memory during those 4 days. As a student who majored in math, it's the first time I have applied the knowledge to solving problems that are so close to real life, which makes me feel excited. Wow. So this person's a math major. They've endured a lot already. They've sort of earned their stripes. But yet this person is saying this is the first time they've been able to really apply and make it feel to real life, and the excitement that comes from the enthusiasm. So when we talk about the whole person, we're talking, remember, about that motivation, what it feels like. Another student said that was awesome. The experience was awesome. Going through this and putting together with the paper where I'm at now, it's just, I'm on the right track. And I know that. It's no longer a questioning, what am I going to do after college? It's, I have an idea and I know that's what I want to do and I feel good about it. So this was a confirming, validating experience for this particular student in terms of, it's not a question now. Now I know for sure this is what I want to do. So they found themselves and they found their home and they found what they love to do with this competition. What do those results mean? Every year, the US sends a team of 6 high school teams, students to the International Math Olympiad based on various qualification rounds. And in the past 11 years, the US has sent 0 girls. So in terms of gender equity, there's still lots of room for improvement. And our question is, what can we learn from the MCM competition that might be able to inform those other competitions? Students need more collaborative, multi-dimensional mathematics. This is appealing to both men and women. So this, again, there's no or here. It's both benefit, both find that all these elements attractive, but it seems to have a more equalizing effect for women. And so here I'll skip over some of these results and say that the slides will be available so you can look at those slides, just in the interest of time. When you connect with a person's mathematical idea, when you connect with another person's mathematical idea, it both requires and encourages a higher level of understanding. So that's why collaboration is so important. In the mathematical modeling competition, 43% are women, and 43% of the winners are also women. Remember how I talked about the results? So this is incredible. So it's proportional. The number of women who participated were equally represented in the award-winning papers. Whereas we know that most competitions exclude girls and women, they offer a culture, unfortunately, that is ridden with anxiety, speed, singularity of answers, and a lot of performance pressure. So this is not how most women choose or want to experience mathematics, according to their survey, according to our results, according to our observations. This is not 21st century mathematics, so we really need to do something different. MCM, we have a comment from a faculty member that says MCM is a different kind of experience compared to math competitions like Putnam. In my opinion, she says, this professor says, it's more accurate reflection of what professional and academic mathematicians do. Reading, writing, working in a team, exchanging ideas, attacking problems that are not initially well-defined, spending time on a problem instead of having a shorter time period, etc. Among other reasons, I recommend this competition for students who want to get a taste of what math research is like. And I recommend it to students who want to go to industry jobs directly after graduation. So I hope this research illuminates and invites you to think about in your role, how can you take these results and apply what we've learned to promote more gender equity. And I don't know if we have a few questions in the remaining time we have, Maria, otherwise.
Yes, thank you, Jack. We have a couple of participants. If you guys would like, I can actually unmute you, or if you'd like to put a question in the chat, we're happy to, I can either read those to Jack or he can see them. So, but thank you very much. It's wonderful to see the research. And the whole time you were talking, I kept thinking so many people need to hear this, because it's such a different way to view mathematics and to think about those students' experiences. So our participants, if you have any questions or comments, we'd welcome those. And again, you can raise your hand at the bottom. If you hover at the bottom of the screen, you can raise your hand, or you can just put it directly in the chat. Looks like we don't have any questions right now. I did have a question while we're waiting to see if the other participants did. Have there been any studies particularly focused on minority students or underrepresented groups in terms of the contest,
No, I don't know. And that would be really, really interesting to do. And I think that has come up as a follow-up research too. So this has a gender aspect, but I think you're right. There are all kinds of other ways to understand the phenomena of inclusion and exclusion, including the intersection of, race and gender, socioeconomic opportunities, and so forth. I think those are all highly interrelated.
There is a question from Christy. She says, are there other competitions similar to the one studied? I'm curious if IMO is more like school mathematics. I'm not very familiar with the competition side.
I don't know of any team-based math competition like that has the elements of MCM. So it's certainly not at this level of prestige. And I wish that we had that. My understanding is that there's also a high school component to it, which I would love to see more high schools participate and have students engage in this kind of work as well. So the short answer is no, I don't know of any other competition that have the same attributes.
Yeah, the high school competition is called the HiMCM, the COMAP competition. And they do have a lot of high schools participate, and it is a global competition. And many, many, many of the high schools are from China, from other countries, but there are American teams. And the other competition that's a modeling competition is the MCubed, which is math modeling contests, that what used to be the Moody's contest, but now it's got a different sponsor, and that too is a high school competition. So you can go to the mathmodels.org website to learn more about HiMCM. I'm actually a judge for that one, and those again are real world problems that students work on, over a couple of days in teams. And I think folks have talked to students about their reflection on that participation, and have talked about similar things, is the opportunity to have more time to work collaboratively, to pool the skills of the team, to work creatively. All of those things, unfortunately, is rare in a high school mathematics curriculum. But we're trying to put little pieces in there. But these opportunities, they do take time, but they are quite impactful, I think, for students. Let's see, there's another question here. No, it just says thanks for the info.
Well, just another thing is that when we give students a challenge, rather than them shut down, if they have enough time, we see high levels of engagement. I mean, some of the students in this competition took very little sleep because they were so committed to their team, so committed to the process, and so engaged with the process that, it wasn't about, okay, time's up, now I'm going to go home and so forth. They really wanted to just live in that moment and immerse themselves in that moment. And I think there's a lot to learn from that in schools, where unfortunately in math class, you can imagine many kids looking at the clock and saying, okay, when is the hour going to end? When we've done this in our interventions at middle school, and granted, they're not at 4 full days, but we've taken several days for extended problems like the painted cube problem and so forth that we do in our summer school program. The kids don't want to go to recess. They don't want to go to lunch. They want to continue working because they see the progress, they get a taste of it, and they start seeing how ideas are building, they start having breakthroughs. So it's a wonderful experience.
Yeah, yeah. And I know that when I've worked with teachers in the past, they often say, this idea of, I can't give up time to let kids explore because of the testing or whatever. If we can really try to move towards what we think about what the benefits of this time that we take with students to kind of let them get in that zone, it's again quite, I think, powerful to see that.
And the richness of the skills that they were using, the integrated way, if you could delineate all the math skills that they were using, it'd be a very long list. But instead of taking that list and saying, okay, today we're going to do this, tomorrow we're going to just cut it up into little pieces, if we present it in a more connected way, then it's not that students are missing this or they're going to miss that. It's really like, how is it that they can see the connections? But it takes time. It takes a little bit of breathing room. And I think it takes a little bit of trust that students can do it. Because I think as teachers, we want to help kids. But unfortunately, that help becomes us explaining, us leading too much, us cueing the students too much. It's all well-intentioned, but what happens is it zaps the challenge right out of there, and it zaps the learning opportunity. So sometimes I think that the greatest skill a teacher can have is the discipline of seeing what can my students do on their own? What can they do with a little bit of assistance, instead of how can I help them be successful so they don't have to struggle at all? Because struggle feels really good when you reach the other side.
Yeah, yeah, that's where you feel the sense of accomplishment, right?
Yeah, that's when you feel like, hey, I made it,
So we're about out of time, but I want to thank you, Jack, so much for being here with me, with all of us. And those of you who attend, if you want to access both the slides and the paper and the recording, that will be on the mathmodels.org website for this webinar. And if you can join us next month on March the 24th at 4 p.m., we'll have a high school teacher share some of his explorations in terms of math modeling. So thank you, Jack, and thank you, participants.
It's been a pleasure. Thank you.
Yes, ciao. Bye.
Ciao, ciao.